Hello friends, welcome to the video lecture series on basic electronics. I am Dr. Alpesh Dafda and today we will study transistor as an oscillator. In our previous video classes we have seen two important applications of transistors, that is transistor as a switch and transistor as an amplifier. One other important application is transistor as an oscillator, right? So as usual, starting with the name itself, what is a transistor? You know, transistor is made up of two terms, transfer plus resistor. A device that transfers the current from a low resistance junction J1 to a high resistance junction J2, right? And what is an oscillator? A oscillator in very simple terms is a waveform generator or a signal generator that generates waveforms at some particular frequency, right? More precisely, you can define the oscillator like this, that oscillators are circuits that generate a continuous voltage output waveform of constant amplitude at a required frequency. Now, how this frequency will be determined? This frequency will be determined by the capacitance, inductance or resistance that is used inside this oscillator circuit, right? Now these oscillations are of different types, right? Not only sinusoidal oscillations. The oscillations may be of square wave, right? The oscillations may be triangular waves, the oscillations may be sweep waveforms, etc. And also the oscillators are of different types. You know, there is an oscillator named LC oscillator. There is one other oscillator which is known as Hartley oscillator. One more oscillator is Colpitts oscillator. There is also RC phase shift oscillator. There is also quartz oscillator, and meanwhile there are many different types of oscillators, right? Now question comes in your mind that what is the use of these oscillators? See, the applications of these oscillators are very wide. One of the most important application of this oscillator is for generation of carrier waves in electronics communication system. Whatever we speak or speech signal or audio signal is a low frequency signal in terms of hertz and kilohertz. When we want to send this signal to a distant place, we require a high frequency carrier wave in terms of megahertz or gigahertz, and this high frequency waveforms are generated using oscillator, right? These oscillators are used in different digital circuits for switching on and switching off the square wave, right? In our lecture of transistor as a switch, we saw that when we provide a square wave to the input of the transistor as a switch, the LED will glow on and off as per the frequency that is provided to it. Okay, so this oscillator is used in different digital circuits, right? These oscillators are used in different audio and video systems. Okay, the signals that are coming to your TV from the TV cable, right, are generated by these oscillators. Even the signals which are coming to your radios are also generated using this oscillator, right? These oscillators are also used in computers for synchronizing purposes, right? These oscillators are also used in your watches, quartz watches, right? These oscillators are also used in alarms and timers, so that the alarm buzz after some particular times, and in timers so that you can switch on or switch off any particular device after required time, right? Nowadays these oscillators are also used in different decorative lights which are lighting as per the frequency that is provided to it, right? So such many applications are there of these oscillators, right? This transistor as an oscillator is also known as a feedback amplifier, right? See, for normal amplifier you get the output signal when you provide the input signal, but for transistor as an oscillator you do not require to give any input signal for obtaining the output waveforms. So hence you can say that the output waveforms are obtained without any external input signal, or the output in an oscillator is self-sustained. Getting it, right? So how to do this? A part of the output is taken and is feedback to the input so that continuous waveforms are attained or achieved, right? So we'll start the understanding of this transistor as an oscillator by understanding a simple LC oscillator. This is the circuit of the LC oscillator. This is the inductor L. This is capacitor C, right? And these both capacitors and inductors are connected in parallel. Now let us assume that initially this plate of capacitor is charged positively and this second plate is charged negatively. I have not shown the negative charges over here for the ease of understanding, right? I have omitted it. So when it is fully charged, the capacitor will start discharging and the direction of current flow will be like this, which will be given by IO or I output current, right? So the capacitor will start discharging in this particular direction and the current will flow like this. So here you can see that the output current is slowly decreasing, right? Once all these positive charges have reached this second plate, right, the current will be minimum, as you can see here, right. This current flow is shown with a blue bold line, right. So once all these positive charges reaches here, right, the current will reach here in the waveform, right. Now what will happen? This plate is charged positively with these positive charges which are shown with black colored and circle positive charges, right. Now what will happen, that this black colored positive charges will make the current flow in the opposite direction like this, which I have shown with the dotted black line, right. So now the current direction is like this, right. So here you can see that the current is increasing slowly as shown in the waveform, right. So once it reach here, right, this particular point, one complete cycle is complete, right. So this is one wave of this complete waveform or of this complete oscillator, right, which is already known to you. Of course, when the capacitor will be discharging, you know that this inductor will have induced EMF or magnetic field like this, right. The energy that is stored in this capacitor will be equal to 1/2 CV square. The energy that is stored in this inductor will be given by 1/2 Li square, right. So this is known to you, but the waveforms you see here, okay, are sustained oscillations, right. Exactly, this LC oscillator will not be giving such sustained oscillations, right. Why? Because there will be losses in every cycle due to these wires which are connecting the capacitor in the inductor, right. There will be losses due to the resistance of the inductor, as well as there will be losses due to the dielectric material of the capacitor, right. And hence the waveform will not be sustained and rather will be damped waveform, something like this, which will die out, right. So we obtain from this LC oscillator a damped waveform or damped oscillations like this, okay, and this output current will damp out gradually with time, right. So this is the same output current, right. Now this output current will be similar to the collector current that will be obtaining for the transistor as an oscillator, right. Therefore I have also shown here IC, right. But for IC the waveforms will be sustained. How? We will just see, right. Okay, so how to find out the frequency of this particular LC oscillator? You know that at resonance the inductive reactance XL is equal to capacitive reactance XC, but you know that XL is equal to 2 pi FL and XC is equal to 1/2 pi FC, right. So taking F towards this side, 2 pi F square L is equal to 1/2 pi C. Therefore F square is equal to 1/2 pi square. I have taken 2 pi this side again, so 2 pi square into L into C, right. Therefore F is equal to √1, taking square root on both the sides, √1 upon under root of 2 pi square L into C, right. And therefore you can say F is equal to 1/2 pi under root LC. Why? Because √1 will be equal to 1 and this 2 pi square root will become 2 pi, right, and under root LC will come over here, right. Now what is this resonant frequency? This resonant frequency is the oscillation of a system at its natural resonance or unforced resonance, right. So that is resonance frequency, right. So this circuit, the LC circuit which we have just seen, this is also known as a tank circuit. Why it is known as tank circuit? Because it stores energy as you store something in the tank, therefore it is known as tank circuit. And it is also known as tuned circuit. Why? Because for receiving the waveforms of this particular circuit you have to tune to this particular frequency of this circuit, right, and therefore it is known as tuned circuit. You have to tune to this particular frequency, right. Now the problem is that these oscillations are damped or these oscillations die out after some particular time, right, and we do not want that, right. What we want? We want that these oscillations should be sustained oscillations, right, and have a constant amplitude. Okay, this waveform should go up to this point, right. Similarly this waveform should go up to this point, this waveform should up to this point, and this again waveform should go up to this point, right? So what can be the solution? The solution is to use a device that will switch on after some particular level, right, and switch off after some particular level, right? So what can be used over here? We can use a transistor, right? Why? Because after some particular level the collector current becomes constant, right, or saturated, and after some particular level the base current again becomes zero or cut off, right? That means if you use a transistor, then you can get rid of this damping of oscillations and you can get sustained oscillations, right? So let us understand the principle of working of this oscillator, right? What we will be doing, we will be taking the output from the transistor amplifier, and a part of that output is given to the feedback network, and that is feedback to the input of the transistor amplifier, right? The condition is that this input which we are feeding back should be in phase with the input that we are already providing. Getting it, right? So let us assume initially that input of this transistor is 1, right? So what will be the output of this transistor amplifier? There will be gain. So say you get 2, right? Now this 2 is again feedback to the input, right? So you are again giving 2 as the input, so output will be 4, right? Again this 4 is feedback from the feedback network to the input, right? So input now is 4, and what you are obtaining will be 8, right, after amplification. Again you feedback 8, right, and what you obtain at the output is 16, right? And this goes on, right, up to the level where the collector current reaches saturation, right? Once it reaches saturation, then it will not increase further. If it will not increase further, it will start decreasing. Getting it, right? Why? Because we are also using an inductor in the circuit, and you know the inductor has the voltage equation of E is equal to minus L di by dt. The voltage equation of the inductor is minus L di by dt, right? Because once the collector current becomes constant, that means there will be no change in the current, and when there is no change in the current, then what will happen? The differentiation of this current will be equal to 0, okay, and hence you can say the voltage generated will become 0, right? But instantly it will not become 0, it will gradually decrease from 16 to 15, 14, 13 and so on up to 0, right? So a time will come when it will become 0 and you will be applying minus 1 volt at the input, right? So what you will get at the output? Minus 2 volt. Again the same minus 2 is fed back to the input and you are applying minus 2 volt from the input. You will get minus 4 at the output. And this goes on, right? Up to which level? Up to the level where IB becomes less than the cut-in voltage, or base current becomes less than the cut-in voltage of the transistor, and hence transistor will become cut off. And once transistor becomes cut off, that means the transistor has reached the bottom level, right? Now again what will happen? The cycle will get repeated. Again one will come from the input. Why? From where this one will come? Now what will happen? The capacitor that is charged will start discharging, and again the current will start flowing, okay, and again one will come, again 2 will be the output, again 2 will be the input, that is feedback, again 4 will be the output, and so on, right? And this cycle will go on if you are using a transistor amplifier along with the LC oscillator circuit, right? And this is the working principle of transistor as an oscillator, right? Remember, from the output characteristics of transistor, which we have already seen in our transistor common emitter characteristics, right? Input output characteristic. For the output characteristics, this is VCE and this is IC, the output current, right? For different values of IB. So you can see here, or you know that after some particular level, okay, the collector current becomes constant. You can see here the collector current has become constant. So as this IC will become constant, that means there will be no change in current for the inductor, and if there is no change, then the voltage will become 0 and again it will go down. okay, and after some particular level, right, the cycle will get repeated, right? So due to this particular interesting property of transistor, we can use transistor amplifier along with the LC oscillator to obtain sustained waveforms, right? So let us understand the circuit diagram of transistor as an oscillator, right? So this circuit shows transistor as an oscillator. So you know this is a NPN transistor, so this will be the arrow that will be pointing towards the common emitter, right? It will be from P to N, or the point of the arrow will be pointing towards N because this is N, right? So this is common emitter, this is your base, and this is collector, and this is VBB that you are supplying to the base, and this is VCC which you are providing to the collector. Okay, you know that this collector junction is reverse bias, right, by using this battery because this is N and it is connected to the positive. Similarly, this P junction is forward bias by using the positive terminal of the battery, right? Of course, detailed biasing circuits consisting of resistors and capacitors is omitted over here for the ease of understanding. For this particular circuit, we have used a LC tuned oscillator circuit at the output side, and therefore this circuit is also known as tuned collector oscillator circuit because we are using it at the collector side, right? There is a capacitor that is used over here, as well as there is an inductor that is used over here, and this inductor is coupled mutually to other coil of the inductor using a common iron core or soft iron core, right? This is the soft iron core which is shown with these parallel lines, right? And there is mutual inductance coupling through the magnetic field from T2 to T1. This is T1 coil and this is T2 coil, right? And of course the output is also taken from T2 coil, which we will mention as T2 dash coil, right? So what will happen due to this, there will be mutual inductance coupling in between this coil, and whatever EMF will be generated over here will be also coupled to this particular coil, right? So let us try to understand the working of this transistor as an oscillator circuit, right? Initially the switch is in the off position, so switching off this switch will make the collector current to flow, right? And that collector current is linked to the input side using this particular coil T1, right? You can see here that T1 is connected to the base side or base emitter side of the transistor as an oscillator circuit, right? So now what will happen, that collector current has increased, so again base current will increase, right? Base current has increased, and that increased base current is coming over here, and again the collector current will increase, right? So again more flux will be linked, and again the base current will increase, and this cycle will continue up till which point? Up till the transistor gains, or up till the collector current becomes constant or saturated, as we have shown here, up till the point where this collector current becomes saturated, right? So once this collector current becomes saturated, what will happen? That IC will be equal to constant, right? When I is constant, you know from this equation, minus L di by dt. If I is constant, then di by dt, differentiation of a constant, will be equal to 0, right? So now what will happen, that the current that is present in this particular coil will become 0 gradually, right? And now that 0 current is linked over here, right? Or a decreasing current is linked over here. So as the current will decrease over here, right, same base current will decrease over here. As IB will become less, from the equation IC is equal to beta IB, again IC will become less, again less current is linked to this coil, and again IB will decrease, and this cycle will continue until which point? Until the point when base current becomes less than the cut-in voltage, right? At that time what will happen, that the transistor will become switch off, right? So now the transistor has become switch off, or we have reached the minimum level of this output current. We have reached the Z level of this output current, right? Initially it was X level, it is gradually increasing up to Y level, then it starts decreasing and it gradually reaches Z level, right? Or the minimum level. So now the current IC has reached the minimum level, right? So now what will happen, as we have seen from this LC oscillator circuit, right? Now the current will start flowing in the opposite direction like this, right? Which is shown with the dotted black line, okay? And again the current will start increasing like this, right? So same thing will happen over here. Again these positive charges which have reached here will now flow in the opposite direction like this, right? And again the current will start increasing, right? So again IC will increase, or say IC has become 1, that 1 is feedback to the input again, and 1 will become 2 after amplification, again 2 is feedback, and after amplification it becomes 4, okay, and again it reaches the peak level of this waveform, right? And then again the cycle gets repeated, and then again the current starts decreasing, right? So that means the losses that were occurring in the tank circuit have now been replaced by the amplifier action, and therefore this is known as feedback amplifier. Why? Because we have feedback the output to the input. This is our output side, and this particular is our input side at the base side, right? So this is how transistor as an oscillator works. The collector current will increase and decrease, and proportionally the base current and even the emitter current will increase and decrease, because you know that the base current is very less, approximately 5% of the emitter current, right? And majority of the collector current is the emitter current. So the emitter current waveform will also be similar to the collector current waveform, as you can see here, right? Here we are mentioning here the collector current waveform reaches X level. At that time the emitter current will reach X dash. When this collector current reaches Y, the emitter current will reaches Y dash. When the collector current reaches Z, the emitter current will reach Z dash, and so on, right? So this shows the rise and fall of ICN due to inductive coupling. Now as this tuned circuit is connected towards the collector side, this particular circuit is also known as tuned collector oscillator circuit, right? If this tuned circuit would have been connected towards the base side, it would have been known as tuned base oscillator circuit. Getting it, right? Now you can see here that the cycle will get repeated, and we have not provided any input, and still we are getting the sustained output waveforms, right? So it is generating AC from the battery source or DC supply that we are providing, and therefore it can also be called a inverter, right? A inverter is one that converts DC to AC. I am repeating once again for your understanding. See, this is the circuit of transistor as an oscillator. This is the input side which we have connected to this coil, and this is the output side where we have connected the tank circuit or tuned circuit, right, which is consisting of a capacitor and an inductor, right? And these two coils, or both these coils, are wound on a common iron core, right? So there is mutual inductance coupling through magnetic field in between coil T1 and coil T2. The output is taken from T2 as shown over here. So this is our input circuit and this is our output circuit, right? Now say what will happen. So initially this switch S is in off state, this S is switched on, and so the output current will increase due to mutual inductance between T2 and T1, right? Current in T1 will also increase or change. This change is fed back to the input circuit, right, or input side. Okay, so now what will happen? The IB, base current, will increase, right? So now the emitter current, which is equal to IB plus IC, will also increase, right? Increase in this IB will increase again IC. How? From equation IC is equal to beta IB, right? Due to amplifier action. When IC increase, voltage change across T2 will again change or increase. As T2 is linked to T1, again voltage change across T1 will increase. So the current will again increase. This goes on till IC reaches saturation, right? Now it cannot increase anymore because from this characteristics, right, it has become saturated, right? So this is due to saturation state of the transistor, right? So since current stopped increasing, the induced EMF E, which is equal to minus L di by dt, tends to reach 0. So it starts decreasing. That means IB will also start decreasing, right? So this decrease is multiplied in collector side or output side, which decrease more IC, right? So this IC will decrease, again this IB will decrease, again IC will decrease, again IB will decrease, right? And this will continue until IB reaches below cut-in voltage, right, or the knee voltage, right? So now the IC will be 0 and IB will be 0, and this is known as the cutoff state of the transistor. Now again the capacitor will start discharging in the opposite direction, right? And IC will start increasing again, and as output is taken from the tank circuit, here, right, we are getting an undamped oscillations. So this will be the change in current or rise and fall of collector current and emitter current due to coupling. So I hope you have understood the working of transistor as an oscillator properly. So that is all in this video lecture. Thank you very much.